welcome to the stage, John DiPaola.
Thank you, Lucian. This is such a great conference. Thank you for putting this all together. I just want to welcome everybody. My name is John DiPaola. I'll be your moderator for today's session called Predictive Maintenance and how Edge AI Sensing transforms manufacturing. Thank you all for joining us. I know everyone's schedule is packed, so we really appreciate you taking the time to be here. Before we get started, a quick thank you to TDK Sensors EI for sponsoring this session. We couldn't do it without your support, so it's really, truly appreciated. As we get going, please feel free to drop a quick note in the chat, who you are and where you're joining us from. I'm here moderating this session from Cleveland, Ohio. It's a beautiful day. Hopefully it's beautiful where you are as well. And it's always great to see who's in the room for us. So feel free to drop a quick note in the chat. Just a couple of quick housekeeping notes before we get started. I'll kick things off with some context and we'll introduce our great panelists. We'll have a great discussion, and we've saved some time at the end for your questions. When you do have a question, please use the Q&A tool rather than the chat. That helps us keep everything organized, and it makes it easier to get as many of your questions answered as possible. So, setting the stage, let's dive in. I'm really excited about today's panel. We've got a group of experts who are working really at the intersection of sensing AI and real-world manufacturing operations. So as manufacturing leaders, I believe you'll get a lot of value out of today's session. We're going to talk about how modern sensing systems are helping teams catch equipment issues earlier, reduce downtime, and ultimately improve both safety and productivity. All important concepts for great manufacturing leadership. You'll hear some real-world examples, lessons learned, and practical advice on how to bring these technologies into your operations without turning everything upside down. By the end of the session, the goal is simple: give you a clearer picture of where things are headed and what you can start doing now to get ahead of it. So let me introduce our panelists. First, we have Thomas Kuckhoff from Omron. Thomas brings deep experience in industrial automation and sensing, really helping manufacturers drive performance through smarter, data-driven systems. Next is Sundeep Ahluwalia from TDK SensEI. Sundeep works right at the forefront of advancing systems and analytics, helping organizations improve efficiency and reliability through intelligent sensor solutions. We're also joined by Steve Blackwell. Steve is the head of Product Engineering and Services Center of Excellence at AWS, with over 25 years of global manufacturing experience. And finally, Greta Cutulenco, founder and CEO of Acerta. Greta has been a leader in industrial AI, helping manufacturers, especially in the automotive sector, shift from reactive to predictive operations. So welcome, everybody. So let's start with some quick introductions, just a bit about who you are, what you're focused on right now, and why this topic matters. Thomas, let's start with you. Then we'll go to Sundeep, Steve, and then Greta. So Thomas?
Thank you, John, and thank you, IIoT World, for putting this event together. The timing couldn't be better, not only on the hardware side of AI, but also on the software and algorithm perspective as well. Little introduction of myself, Thomas Kuckhoff, Senior Product Manager at Omron Automation. And I kind of started my career more in engineering and then moved to business, which simply means I'm as much of a fan of an elegant solution as I am a really good problem. And of course, while that common thread meanders through my for-profit and nonprofit work, I'm really more excited to dive into edge sensing space today with Sundeep, Greta, and Steve, because the hardware of sensors is allowing a lot of great process data to get into the edge, where a lot of those more advanced algorithms and more efficient algorithms can really separate the signal from the noise. And it's going to make for a lot of great conversation today.
Awesome.
Yeah.
Sandeep?
Yeah. Well, hey, good morning, good afternoon, and good evening, depending on where you're joining from. John, first of all, thank you for moderating. Really appreciate that. And great thanks to IoT World for pulling this panel together. I'm happy to be joining these great panelists with me. I'm Sundeep Ahluwalia. I am the Chief Product Officer with TDK Sensei. So I very much focus on defining products and roadmaps for manufacturing and heavy industries. Having been in the heavy industry world for almost over a decade, so put together solutions like predictive maintenance and bringing in AI agents to deliver outcomes for our customers. Really happy to be here and look forward to this discussion.
Awesome. Steve?
Yeah, I just want to echo the other panelists. So thank you, John, for moderating, and thank you for IoT World for having us on the panel. Yeah, as you said in the introduction, my team, or what I'm responsible for at AWS, is the product engineering and services team, which is part of our manufacturing center of excellence. So we work with manufacturers to really help them kind of transform their value chain, across from R&D to smart manufacturing to supply chain to smart products and services, and really how AI can really enable that. And I'm sure we'll get into it a bit, but when we look at AI, it goes everything from traditional algorithms through to kind of agents to help drive kind of process efficiency and kind of automation. And I'm in starting my career very similar to Thomas as a engineer. So I love how things work in kind of building. So I get very excited when I'm working with manufacturers and even kind of automation machine builders to help them kind of build this technology into their solutions to offer it out to the industry. So
Great. Thank you, Steve. And Greta?
Perfect. Hi, everyone. And Simone, thank you for having me, and excited to be here amongst such a great panel. My background is I started similarly as an engineer at a major automotive manufacturer called Magna. And so spent a lot of my time in production, both in quality and process optimization. And so one of the things that always really excited me was just the growing amount of data in production with all of the digitalization efforts, and especially how that can be used to transform how manufacturers are approaching quality, process optimization, and efficiency in production. And so excited to chat a little bit today of what we've done and some of my observations in the field.
Awesome. Great. So thank you, everyone. Really impressive backgrounds. And just a quick reminder to the audience, keep the questions coming in through the Q&A. We'll get as many of them answered as possible. And there's no need to wait to the end. So hopefully we get enough time to do that. But before we jump into some questions I have for the panel, here are, I think, three things that we want to keep in the back of our minds as we listen to our experts. First, what is the right balance of maintenance strategies for your operations? Think about that. A lot of organizations are still heavily reactive, but we're seeing a shift towards really a smarter mix of predictive versus planned and reactive type of approaches. So, there's not one size fits all. So how does that blend together in your particular operation? Second, where does reliability matter most in your operation? I said, it's not a cookie cutter approach, right? Not every asset needs the same level of investment or prioritization, but prioritization is certainly the key. And third, what does it really mean to run AI at the edge, right? Closer to the sensors. How does that impact speed, scalability, obviously reliability, and decision making on the plant floor? So think about those three kind of data points as we go through our discussion. So let's get into it. First question goes to Sundeep, and we'll start there. Not all environments are created equal, right? So how do you define success with predictive maintenance? Is it downtime reduction? Is it longer asset life? Is it fewer emergency repairs or something else?
No, no, thanks, John. So, every customer and their process and the process complexity is very different. So you got to have that context of what customers' process is like. And, as I go across, talk about our predictive maintenance with many customers, someone will say, hey, I want a 2-month advance notice or a prediction that the machine might fail, and hopefully can catch it in one of my maintenance cycles and fix it before it goes down. And some others are like, well, hey, we have a very complex process. We have a lot of product to ship out. It's good to know it's going to fail, but I'm going to look at the product quality, and I will, as long as quality is good, I may not touch it until the very last minute I have to, right? So you have to have that understanding and context of what customers' needs and pain points are. Having said that, I think the number one thing that I think is talks to about success is trust. Have you gained the customer's trust with your predictive maintenance solution, right? You don't have false positives, or every time you make a prediction, it's actually a true prediction. So building the trust with the customers is the number one sign of success. They adopt it, it becomes part of their process. And of course, then there's all the metrics that everybody wants to look at, right? Hey, did we avoid unplanned downtime?
Yeah.
Did we actually extend the equipment lifespan? Or hey, did we overall reduce the maintenance labor costs and things like that? So all of those are metrics that, of course, will come through if you have built that trust with the customer and your predictive maintenance solutions with enough data, with the AI solutions actually provide that true prediction. So I think to me, those are the key elements that as a solution provider, we look for in providing to our customers.
Great. Steve, building on that, what do you value most from like a cloud and AI technology partner? Sandeep talked about partners and clients and those types of solutions and trust. When we're talking about maintenance solutions, how do you value that type of interaction?
Yeah, so I think I'll start off and from my perspective, predictive maintenance is hard to do, at production scale.
Right.
Very easy to do probably from a POC perspective, like one asset, one machine, but to do it at scale across multiple sites is hard. The reason why it's hard is because just the amount of data that's required. So, and it's a combination of, data like the IoT sensing data of exactly, the temperature, vibration, pressure flow, whatever it may be. But then all the historical maintenance records, the tribal knowledge of all the maintenance engineers that have been performing and maintaining these assets for like 10, 15 years. And it's the crux of it, it's, the initial part is very much a data scientist kind of project where you've got to, ingest all this data, into where I see the cloud adds value into your industrial, data lake. Give the data scientists the ability to, analyze, see that data, work alongside the manufacturing engineers, the process engineers. They're going to bring the business knowledge so they can get to a point where they've got like a data set they can actually use to be able to then train a model. And then to Sandeep's point, can they validate that model that it actually works per kind of the business kind of, KPIs.
Right.
And really where, we see our value and kind of with our, partners, is providing kind of that infrastructure cloud capability to be able to collect the data, validate the data, build the models, validate the models, And then when you get to the scale perspective, being able to then, in some instances, be able to deploy those modules down to the edge, to run across, your multiple sites, your plants, and so forth. So,
yeah. Do you see a difference there between small manufacturing companies, mid-size and large? And can you talk about that?
Yeah, I mean, it generally comes down to skill set of what we see. A small to medium, size manufacturer probably only has maybe like 50 people, in the facility. And they probably definitely don't have any, data scientist, capabilities or IT people. In those instances, we generally see that, those manufacturers want to buy a solution from a, predictive maintenance software or automation, partner, and really
Right.
can't have a canned kind of capability. The larger manufacturers that probably have a lot more kind of complexity in their processes, in their variation of machine tools, pumps, sensors, will probably then kind of build their own kind of capability. I use the word like center of excellence, where
Sure.
they can bring the skill sets in, they can marry the business and the IT people to work together as like one team to be able to then do this, at scale.
Yeah. Thank you. Thank you for that. This next question goes to Thomas. There are a lot of manufacturers working in brownfield environments. How can they introduce edge AI and predictive maintenance without disrupting what's already in place?
Yeah. I'm going to build on so much what Steve kind of laid the foundation for, because predictive maintenance is difficult. It's difficult because of the inherent complexities of either what you're building or the environments. That's when we talk about these brownfield facilities, Steve was 100% right. These facilities have been around for decades. So any sort of introduction of edge AI should be focusing on the process data first. What I mean by focusing on the data to start with is beginning with a non-intrusive data collection pilot on the native protocols that are already running through the factory. So a lot of these brownfield facilities have a number of different protocols, whether they're globally open or they're proprietary, but that's already where the data is moving and where a lot of those signals are traveling throughout the factory. So begin with those native protocols, and a good first step is just doing an inventory. What are we using to make sure that our goods and our processes are running as efficiently as we believe that they're running? So of course, when we look at these pilots, definitely want to throw in that asterisk of keeping that endpoint security in mind. But definitely would not recommend rewriting all the PLC logic, changing recipes, or ripping and replacing control systems as a whole, but beginning by just observing the process, collecting the data that's already there, and then building a baseline around a stable, well understood asset, because a lot of those well understood assets are the cornerstone of a durable competitive advantage, which of course shows up on a P&L statement. So focusing on that data first can really help not disrupt a process, but also reveal in these brownfield facilities where the gaps are in their data narrative, which of course kind of fill into that data like that Steve outlined. And by focusing on that data first, of course, you're not ripping and replacing, but it also helps a lot of brownfield facilities make better decisions when partnering with an AI partner or a preventative maintenance software, which of course, good news is we've got a number of those experts on this panel as well.
Okay. Thank you. That's very, very excellent. Thank you. And Greta, predictive maintenance has been really strong. It has its roots in continuous manufacturing. How is it evolving in more discrete type environments where there may be more variability in the manufacturing process?
Yeah, that's a great question. And that's something we have observed. A lot of our work to date is in automotive. And that's a very discrete production environment, right? You're producing part by part, you're spending a little bit of time on each component. It's a very stop and go kind of production environment where you're basically, there's changes from shift to shift, from part to part. Your equipment's not always running, compared to, let's say, more continuous environment where you might be running the same piece of equipment for hours and just observing how it's performing. And so what we've found in these more discrete production environments, again, coming to something that the panelists have mentioned, you have a choice between augmenting through new sensory equipment or using data that's already existing. And what we found is that kind of, again, if you're creating a sensor in addition and including new sensors on the equipment, of course, it creates some amount of consistency, because especially in a discrete production, you might have such a variation in machinery. So that could be one way to accelerate and have that interesting baseline. But in many cases, if we're starting to leverage data that's already existing within these machines, which is a lot of it out there today, it is a more it's a journey for sure. And oftentimes what we see is, especially in discrete, and what we recommend is starting with condition-based monitoring as a result, because it's really kind of a good way to start looking at changes in condition, changes in performance, as opposed to trying to right away predict that time to failure, which, especially in a discrete production situation, is very difficult.
Right. Thank you. This question is for Thomas. Thomas, you mentioned, it's not necessary to rip out all the logic out of the PLC and systems, control systems that you might have. But there's a lot of debate right now about, where that intelligence, should live. Should it be at the sensor level, at the controller level, at the gateway level, or just simply in the cloud? How should manufacturers be thinking about that right now?
All right. So when we look at where to put intelligence, you definitely want to put it in a location where it can act responsibly, timely, and also securely. The mistake we see is that teams want to put all solutions into one layer, be it at the edge or all the way in the cloud. And intelligence also can, if it's put in the right location, can have that nice balance of latency, data context, of course, security, but also balancing the operational risk, especially when bad actors would love nothing more than to get into a network. So I'm going to build off of Sundeep's answer in that first question, which is focus on what the problem is on the factory floor, and also what success looks like. Sometimes a good decision made quickly is much better than waiting for the perfect answer, because of course there's a lot of changes on the factory floor. So maybe sensors and IO, they're definitely great for high fidelity signal capture. So if there's logic intelligence there, that's a great place to focus on, saying how do we get as much data as possible. And of course something like IO Link is a great way to look. When we're at the controller level, having whether it's one core, multiple cores sharing memory, you've got that deterministic control, which allows teams to respond very, very quickly, although the logic can be rather basic. Of course, gateways and industrial PCs are strong for more advanced edge analytics, and then the cloud is so powerful for that fleet level learning, managing your models, and of course any sort of visibility across the enterprise. But I will throw the asterisks in this as we continue to talk about IT technologies and of course those OT experts. These used to be two households, both alike in dignity, and as an architecture scales, you might need to increase one or the other, adding more control as you start to identify, okay, we need to add more motion here, we need to add more sensors here, versus saying, okay, now we want to add more intelligence. Let's make sure that there's a right place for that, and that could be at the edge level, but it can also be at the cloud level as well.
Yeah. Great, thank you, Thomas. What's nice is that we're getting questions and we're answering those questions in real time, whether we realize it or not. So that's great. We're doing well from that standpoint. I have a two-part question, and I'd like to ask Sundeep and Steve to kind of team up here maybe a little bit and get your perspectives. Um, um, we talked a little bit about integration here and how important that is, and how you bring predictive insights into systems like, maybe MES or CMMS or ERP systems without overwhelming the operators, right? Which is critical. So, how do you do that? Number one. And number two, when evaluating edge for AI, for example, for predictive maintenance in this particular case, what factors really matter most to you? So, Sandeep, maybe you want to start with that?
Sure, sure. I'll maybe start with your second question first. It kind of adds on to what Thomas was talking about, kind of the same theme,
Sure.
which is that, you have to look at your deployment and then decide your strategy on, your edge AI. TDK Sensei, we do run AI models on the sensor on the machine, so it's very machine specific. But there are scenarios where customers may say, hey, I do want you to integrate with my MES system or on PLC, and based on what you see, send a signal or receive a signal, or act like on a different state machine, for example. So there you want to be on the edge, because latency might be an issue there. So there you want to run something on your edge AI server on the premises so that you can actually get inference from your sensor, but also take actions based on that within the factory as well. So really, your deployment, comes on when you go in and look at the customer premises and see what you want to do, understand the process and what outcomes they want, and design that deployment model based on that. Now, moving on to the integrations, I think the one thing that's, I think, key is not to overwhelm the customers with data. There's so much data, and you don't necessarily need to take all the actions based on what you see with integration. Each integration has a different purpose, and you may not need to send the data. So you want to be able to contextualize everything and give just the right information to your customer, because they are used to data. They know it, but we can generate so much data, they may be well overwhelmed by it. So for example, I think one of the things we talked about is predictive, but from predictive, as you move on to prescriptive, right? Here I can tell you what's failing, but let me tell you what might be happening and how you can fix it, right? And based on that outcome, you tell the customers. And then we see this trend towards this agentic approach, right? Where a predictive output gets into an agent, and agent says, hey, let me take a look at what might be the problem here, for example. And where I'm taking this is that you might still have the integration with the CMMS and MES, but what information you send to each system will depend on on the output, right? And the ERP as well. So it might say, okay, looking at the maintenance logs and machine manuals, I believe this will be the fault. Looking at other similar machine types, this might have failed. And then let me go see on the ERP system whether these parts are even available in the inventory. If not, can I order it, right? And then let me send a maintenance technician who had worked on this machine in the past, how they can go fix it, right? So all these different systems have different answers that need to go to it. But again, this goes back to my earlier point, which is this requires building trust with your customer. Nobody's going to let you do anything on their machine without them saying, yeah, I trust you. This system has worked in the past, and I'll let you go do it. Or there may be in the middle, right? They may approve things in the middle that allow you to do some of those things. So overall, I'll say that the main thing is that understand the customer's premises and their problems, and put everything in the context in which they can easily understand and take actions on it.
Steve,
Um,
your thoughts?
yes, I mean, I would say, and this is a very kind of blanket statement, with predictive maintenance, you're predicting something that's going to happen, a failure is going to happen in the future. And it's generally not in the next couple of hours. It's probably going to be, hopefully, the predictive maintenance solution is predicting something's going to fail in like 2 weeks, a month, kind of 6 months. So you can actually do that maintenance. So when it comes to the actual model inference, we generally see that's running in the cloud because you can take advantage of like on-demand compute and, the low cost of storage and running that inference. Where we really kind of see, building on what, Sandeep said, um, is where AI can really add value at the edge is enrichment of that data and through two context point of view, which is, if I'm running a typical process and I'm monitoring a PLC that's controlling a motor, potentially there could be, hundreds, maybe thousands of tags that are being updated, every couple of seconds. I don't want to bring all that data from the edge up into the cloud to fill my data lake to actually be able to build those models. Because I'm just going to turn my data lake into data swamp. I want some level of intelligence behind what data I bring up, especially once you've gone from initial investigation to actually deployment, because what you want is the edge cases of we haven't seen that data set before, we haven't seen that particular scenario in this machine or asset. So having, a model running at the edge that can actually analyze the data, enrich that data, so that when it comes into the data lake, the people have got a little bit more kind of context around it. We see real value, especially when you've got lines or production cells that may be running multiple different products, SKUs, materials, because one set of parameters trained on, a particular part going down the line may be very different to a set of parameters for a different product, even though it's in the same kind of tolerances, because that product's been manufactured, the upper and lower limits may change type things. So having the ability to enrich the data and add intelligence to data as it comes in is kind of really, valuable. The second part, and Sandeep said it as well, where I really see, value is where agents are coming into this. If I've got a predictive maintenance model, it's going to predict a particular asset's going to fail. That shouldn't be just a feed into a dashboard, because dashboards are only great if people are actually looking at those dashboards. Where the real value is going to come, as Sandeep said, is that you've got a prediction that's going to failure. This is where then kind of agents come in. Agents can take that, as Sandeep said, look into my inventory. Do I have these parts available? What's the cost to actually, replace this part? Do I have any technicians, available in the next 2 weeks? When's my next planned outage? Pulling all this information is sitting in kind of like your ERP system, your MRO system, your CMS system, pulling it all together. And then the real value for me is then creating a ticket in the maintenance system for that maintenance engineer to perform that kind of task. Traditionally that process, going from this is going to fail, have I got the right parts, can I schedule this, could have taken maybe 2 weeks and interacted across probably 3 or 4 different people on the shop floor. With a agent deployed that can actually interact with multiple systems, and to Thomas's point, done securely, and make sure you've got no data leakages. That process could happen in 30 seconds. So this is a real value add to manufacturers of savings.
Great. I think it kind of made me elaborate a bit more, Sandeep and Steve, in terms of, one of the questions from the audience came in is like, what is the biggest gap in AI and edge computing right now? If there was one, what would be that gap? You talked about all this data coming in and all these dashboards, and there's all these processes in place. Where do we see the biggest opportunity, but problem, but biggest opportunity as well?
I think it comes down to data in the end of the day, and how good is your data, how much data you have, because all of that leads to your efficacy of your models, right? And really, and customers actually have a lot of data, and they don't know often don't know what to do with that data. So can you take that existing data and build a more mature model and deploy it so that it works on day one at a certain level of maturity? So I would really say, I think getting the right set of data, clean data to build your models on. And then, of course, getting the contextual understanding of of the customer's operation is also very key. So a lot of people have the solutions, but they never really have the full contextual understanding of how this operation works, what are the pain points. And another thing that I think keep abreast of is that as people are retiring, that resident knowledge is also leaving the company. So you want to make sure that your systems can come in and help new people that are coming in with the knowledge gap as well. So I think really it really comes down to that. One of the things that I think TDK itself has one of the world's biggest manufacturers. So there's a lot of learning that we've been able to get in the manufacturing process to build that contextual understanding around our solution.
Great.
Steve, anything you want to add?
Yeah,
And
I mean,
Thomas, I'm sorry. I think Steve, go ahead, and then we'll go to Thomas. Thomas had a point.
Yeah, I was just going to say briefly, I think today, pure technology, is there, can actually deliver the kind of capability, to the Sandeep's point, the biggest gap we see is the tribal knowledge. Bringing industrial IoT data in is relatively, I use the word relatively easy. But, I've got a maintenance engineer that's been looking after this line or machine for 15 years. They've got so much information in their head around how that machine operates and, previous failures and what they did to actually, fix those previous failures. Gap is like, how do we extract that, information from them, and what we've seen is, if the evolution of AI and like large language models and being able to record conversations and actually, take those transcripts and extract, key bits information to fill those gaps in that tribal knowledge to feed into the data set is really kind of advanced significantly over the last year to 18 months.
Thomas? I think you had a point.
Sandeep and Steve, I couldn't agree with you more. From the sensor technology, we're seeing IO-Link get much more ingrained into a wide range of sensors. From the AI side, we're seeing AI, I'll cite even some of the automotive industry, do some pretty miraculous things. But when we look at what is that biggest gap, it's definitely the trust. It's definitely the tribal knowledge, but it's also the willingness for teams to volunteer that information. You can go on to any media site and see a host of layoffs citing AI. So of course, when teams start discussing bringing AI onto the factory floor, some teams are going to greet that with how anyone would greet heresy. So being intentionally inclusive and inviting the whole range of stakeholders to the table to have the conversation around how this technology is going to be used to help everyone really has a lot of value. So the recommendation from this side is more so now than ever, people want to be treated seriously. So treat them seriously, have the discussion, and show that the goal of this technology is to do more with the current resources we have versus doing the same amount of output with fewer resources. And by including everyone, you'd be surprised how quickly teams are wanting to volunteer that tribal knowledge so then they can do more. And of course, they're not getting the phone call at 5, 6 p.m. during their kid's t-ball game that a machine went down.
Yeah. Thank you. And Greta, this is for you. And we just heard a lot of talk about data and that we don't want to overrun customers with all this data. And we kind of grew up like the more data, the better. Data is king. But more data doesn't always equate to better outcomes. So how do you work on making sure that data is meaningful and really tied to real operating conditions?
Yeah, and I'll echo a lot of what the panelists have been saying as well, is that primary thing we often look at, it's not about volume necessarily, but the density of information and what you have available, right? So a lot of the times, in production environments, we're looking at a combination of both, your process parameters, your machine parameters. There's information about what parts you're sending through the line, right? Because a lot of the time there's a lot of variation in the type of products being produced, and ultimately the quality coming out of it. Because a lot of the times the condition of the machine and how well it's operating has direct impact on the quality of the product. So, and that's one of the kind of the just direct sensory information and outcome information from production. But then you couple that with all of your maintenance data. Is there been something done to the machine? What was the fix applied? Did you change the parts in the machine? So all of that together creates that context, right? So the best approaches we've seen is really that combination and enriching of the data, similarly with that context of not just what the sensors collecting, but also what is that contextual information about what's being done around the machine and its operation. And combining that together, it kind of it removes just even just the importance of which model you really choose, because there's so many options. You can do machine learning, AI these days. You can choose Gen AI. Really, there's a lot of different models can be applied, but it comes down to that context in the data plus the pipeline you're putting in to actually extract the right information, to make your detection, to make your prediction, to ultimately drive up that trust.
And in our previous discussions, we talked about the maturity curve and, companies start using their PLC data across different types of environments, different types of machines that they may have. Can you talk a little bit about, what that maturity curve looks like in the real world?
Yeah, and oftentimes, honestly, when we start with companies that tell us, we want to be predictive, or we want to do predictive maintenance, oftentimes, I see that they're really starting to look at variability in the condition of the machine and identifying when is something changing in the way that that machine is operating. And doing that right, especially in discrete environments where you're producing so many different variations, is also very challenging. So oftentimes phase one is just getting that early indication that the condition of your machine has started to change before moving towards that. First is that predictive piece where, hey, it's not just changing, but kind of as Steve mentioned, it's going to change and drive to failure within the next 3 months, so that you have that early indication. So we often find that as kind of a step 2 from that maturity. And especially if you're starting with, PLC data, with data that you're already collecting, where you're still identifying gaps, you're still identifying those quality issues in the data. And then ultimately, as Sundeep mentioned, driving that towards prescriptive, because as we get that sense and feedback from the technicians on the floor, we can start incorporating that and really start textually driving behavior in terms of how we're maintaining the machines, what should be done. And that's kind of that last stage. So having that progression and maturity, and kind of as the data aggregates, you're really not waiting until that perfect final step on the data, but really adjusting with that environment and really making use of the data and deriving value as you go.
Awesome. One of the attendees asked, that's a great question that kind of leads us into the last part of our discussion, and that's the statement really is more a statement than a question. Is observing users' context directly is far more valuable than producing terabytes of data that don't drive business outcomes. So, we've covered a lot in the first 45 minutes here about strategy and prioritization and edge AI, but maybe talking about the human side of this. I think Sundeep talked about customer trust as being really a critical thing. And I'd love to open this up to the full panel. So feel free to just come in whenever you want with a few quick key questions. Hopefully I have 4 of them. Hopefully we can get to most of them before the session ends. But one of them are, what are the most common mistakes companies make when adopting predictive maintenance, and how can they avoid them? I think we talked a lot about that, but maybe let's summarize that a little bit so we have some takeaways. So whoever wants to jump in.
All right, I'll You guys okay if I give it a
Absolutely.
first? Okay. So
100%.
at least from this side, one of the biggest misconceptions that at least we see is that predictive maintenance is a way to fabricate value from thin air. In reality, it really leverages an existing value and makes it more so. So for example, if your organization is fantastic at making, let's say, bearings and has a static capacity far beyond anyone else's, focus on how does that predictive maintenance ensure that your tools, your polishers give you the highest quality and make you even more so. So focusing on where that value is that Sundeep outlined is definitely a big one. Making sure that again the data that you gather in your pilots is able to fill those gaps and give you that density that Greta outlined. And then I guess lastly is the way to overcome this is as new processes emerge, be flexible to say, okay, we want to change our process. This is how we want to view our data. Since, yeah, I guess no plan survives that first contact with the enemy.
Anyone else want to add to that?
Yeah, I think Thomas covered it well. I think Greta mentioned, condition-based monitoring right earlier, and that was just that tells you when the machine actually just failed, right? Hey, machine failed, and predictive is taking you to the step like I'm gonna give you a prediction well ahead of time, so you can do something about it. I think the expectations also need to be. I think customers say, okay, does your solution work only if the machine fails and you tell it to it failed? But that shouldn't be the way to look at it, right? I think a prediction is telling you something, and your own kind of know-how and knowledge about the machines and history will help you kind of make that decision on how to act on that predictive knowledge, right, or predictive warning, for so to speak. So I think the for customers to see value, machine doesn't have to fail. Number one, so they have to actually be able to resonate with that predictive alert and diligence. And then, as I mentioned earlier, with AI and all that stuff, more and more information is coming to give customers on the fingertips the prescriptive analytics on what to do and how to evaluate that. So I think really the value statement is more about how this AI will grow within their facility and within their context to give them more value. And I think that's the way to kind of look at it.
Along those lines, what do you think to the panel like might be preventing companies from scaling AI-driven manufacturing? Is it cost? Is it technology? Does it wait and see? I don't want to be the first. What does the panel think?
Um, I think that there's a couple of factors. One, I think everyone potentially people see AI as this big overarching cumbersome thing, um, which it is from a kind of a technology point of view, but from a manufacturing point of view, it's lots of small components that actually address the particular kind of use cases and so forth. You know, I know we're talking about kind of predictive maintenance here, but AI can be in the form of a algorithm that's looking at time series data for condition-based monitoring, for example. It could be, a traditional machine learning model that's looking at images for kind of quality defect detection and so forth. So I think it's very much look at one is actually not thinking it as this one humongous thing, but actually looking at each of the individual business problems and going, okay, what's the right part of AI? I say part of AI. What's the right AI solution to actually address my particular use case? And then kind of getting the business value from that, and then kind of scaling out. The other thing I would add on to that is, at least from an AWS point of view, we like to look at things in kind of 4 to 6 week kind of time box. I have been with some manufacturers that have gone, we're going to do this big transformational predictive maintenance program that's going to take 2 years. And generally, when that actually delivers value in 2 years' time, the business has moved on. Whereas if you can show value, in 6 weeks, 3 months time, that allows you to really be able to iterate and pivot, you know, um, based on the current, business conditions. So.
A lot on top of what Steve mentioned, we've similarly seen a lot of initiatives that haven't gone quite well, or initiatives with where companies try to boil the ocean. And I feel like there's a lot of, especially within the engineering kind of manufacturing environments, as a result, people who maybe lost some of that trust in some of the solutions. And we're seeing some of that happening today as well with some of the Gen AI efforts where, it's trying to do everything and then kind of backfiring in certain cases. And so really phased approaches where you build that trust up before getting to perfection, I've seen work very well, where you're showing that ROI early on rather than in a very long period of time, really has people buy into it and drive adoption. And I think that's critical, especially for certain environments where, you're not just, you don't have automated equipment everywhere. You still have that hybrid operations. I think that's really critical to have buy-in of the people on the production floor, that the technology is helping them run faster rather than introducing extra work.
Greta, is it more training or is it more change management thought in the thought process? Like understanding that we have to change. If we don't, we're going to be left behind. Or is it just product technical training? I mean, I think it'd be a little bit of both, but where do you see the biggest need?
I'd say where we've seen the most success is locations where you have a strong set of champions that basically believe and have seen the technology work, and that way spearheads that buy-in across the organization. And so to your point, I don't necessarily feel like it's as much training as much as demonstrating how challenges can be solved in production using some of these new advanced technologies. Because I'd say as engineers, frequently it's, you still want to go in, like, especially if you think maintenance, you want to listen to that machine. I had a customer also give an example that, now that there's a lot of cameras in the facilities, you have some engineers that don't want to go to the production floor. They want to just, see everything through the camera, calculate it all through the camera. So I think it's all just demonstrating what's the best way to use the technology to achieve results, and that way getting that buy-in so that, we're seeing that adoption go quickly. Training definitely helps, but I think it's really comes down to use cases, case studies, and real demonstration of use of AI, and not just visualization. We see a lot of visualization technology be very successful on the production floor, and it's really taking that next step.
Awesome.
I totally agree with Greta on that one, because I think proof points, those POCs, all are meant to prove out that, hey, your solution, which is purpose built for this industry, really does work and does solve the problem that's set out to solve. So I think having those case studies, having those proof points will really help close that lack of understanding of what AI can do for them. It's really essential.
So we're going to be wrapping up in a few minutes here. So I'd like to open it up. I think I reviewed all the questions. I think we've answered them one way or another. If more come in the next few minutes, I will. I'll look for that. But we're getting great feedback from everybody. But any final comments from the panel?
Yeah, maybe from this side, we've talked a lot about gathering the data at the sensor level and having the discussion with both operators, IT teams, and operational leadership to say where is the best place for this intelligence to sit, but also want teams to keep in mind, especially in brownfield facilities, the bandwidth of your network. Again, these facilities have been around for decades, and in the 80s, 90s, no one was building network bandwidth for these technologies. So definitely keep that in mind as you're looking to deploy your pilot, not only from a security standpoint, but also not shutting down your entire network. So as you have those discussions around your pilot, keep in mind not only the value of the edge from the speed perspective, but also the ability to compress data and share it across the network without shutting down your production facility.
Any
No,
other
just add
final
on that. I
comments?
think Steve
Yeah.
touched upon it very early on that I think for factories and manufacturing sites that are trying to build their own AI, there may be a knowledge gap, there's an expertise gap in some of those areas. There are solution providers out there who can come in and deploy a complete solution and get them to the richness of outcomes really much faster. So, I would say don't be afraid. You don't have to invent everything in-house. There are expertise out there that can help you bridge that gap.
Yeah. Yeah, kind of just adding on to that, and I've seen a couple of questions around kind of what's the minimal deployable size, how could you see value in kind of like 6 weeks? Really there is no minimal deploy, size, really. I mean, it's really for me on the business value, the ROI. You could be, a a manufacturer with 100 employees, and you have one refrigeration unit chiller that has a single pump that, if that pump or motor breaks, that chiller goes offline, and then basically production stops, or your product is spoiled for whatever reason. So being able to do condition-based monitoring or predictive maintenance on that pump motor is the real critical factor. And focus on just deploying it for that one thing could actually save you hundreds, thousands, maybe millions of dollars in potentially lost revenue. So scoping out is really key. And starting, I would say, go back to 6 week point of view, starting small on a particular use case or asset. Segregate, can we collect the data? Can we understand the data? Can we actually start to look at anomalies in the data? These are all kind of gateways or gates you can look at as part of the process to show are we on the right direction? To the point, don't go, Greta mentioned it earlier on, a CNC machine, is very, cyclical, and runs multiple different parts. So, if this is your first predictive maintenance project, I wouldn't suggest doing a CNC machine because there's a lot of, variabilities in that. Whereas, a pump or motor, it's probably a lot easier to do from kind of your first project, perspective. And, to my example, could add a huge amount of value, for that particular manufacturer.
Well, we're just at time, so perfect. I'll wrap things up. First, Sundeep, Steve, Greta, Thomas, just a big thank you for your time and your expertise. Really appreciate you sharing your stories, your insights, and your experience. And again, I want to thank TDK SensEI for sponsoring today's session. We couldn't do this without you, of course. And of course, thanks to everyone for joining and for all the great questions. Up next is our next session, AI hype versus reality. What's real, what's working, and what's next? Hope you stick around for that. Thanks again, everyone.